So if I have a plus b parentheses squared, now a lot of people are comfortable with just write it out twice and then what? What did you do on the exam? You FOIL it, right? You write out twice, you FOIL it. I see some people just like, oh, I'm just gonna distribute that square, a squared plus b squared. That's wrong. Remember, you only allowed to do if what? If between a and b are what? Multiplication or division, right? If between the letters there's subtraction or addition, do not do that. You're supposed to write out twice and then FOIL it. I also show you how to do the patterns. You guys remember the pattern? Something squared plus 2 times something plus something squared. Remember that? The pattern? A while ago. So it's going to be a squared, right? So that something will be a. And then so the last one also b. And then the middle one will be what? A times b, right? And the same thing is true for subtraction. All you do is change them instead of plus 2 minus 2ab. So that's called perfect square trinomial, right? Something that you, if I give you a trinomial like this, you can turn it into like that by factoring, right? So we're going to do reverse engineering. Before I give you this, on the exam one, I give you this, and then I ask you to expand it by whichever way you feel comfortable, either FOIL it or using the pattern, right? Now I'll give you this, and then I ask you to factor it back on that. Right? So reverse engineering. Okay. Before that, let me talk about some geometry. Did you guys take a lot of geometry in high school? I remember I did. I don't know why. Back home, geometry is much more important than trigonometry. I don't know why, but I took a lot of geometry for some reason. Okay, so if you take a look at the first square or the first rectangle, well, it's square, right? A plus b, the length is a plus b and a plus b, so it's square. This rectangle is square. What's the area of a square? Can someone remind me? The area is what? What's the area of this square? Or what's the area of any square? Yeah, two lengths come together, right? And they're the same. So a plus b times a plus b. So length times length. In this case, the length is the same. So a plus b times a plus b. What's a plus b times a plus c? I can rewrite it. What? Oh, but let's FOIL this. Let's FOIL this. A times a is a square. A times b is ab. B times a is same thing as a times b, right? Plus another ab, and then last one b times b, b squared. So far, so good. You know this, right? Nothing. What should I do next? Yeah, combine like term. These two are like term right here. So equal a squared plus 2ab, right? Because there's a 1 here and the 1 here. We just don't write it out, but there's a 1 there. So 1 plus 1 is 2. Plus b squared. So far, so good. All right. What a plus b times a plus b equal? If I ask you what's x times x, you say what? X squared, right? So a plus b times a plus b is no. Okay. Don't write this down. If I ask you x times x, you say it's x squared. If I ask you a plus b times a plus b, you say what? A plus b squared, right? This first power, you add the powers, right? You keep the base, right? So the base here is just a bit more complicated, right? It used to be x, but now it's it's the sum, right? The base is the sum. So let me erase that. So a plus b times a plus b, I can rewrite this as a plus b squared. A plus b squared. So what does that tell you? Okay. So this equals this equals this equals this. Yeah. So if I give you this, can you reverse engineer, go back to that? By doing what? By doing what? AC method again, right? AC method again, and then group factoring, right? And just go work your way back to that. So that's what we're gonna do today. Right. Well, one more time. So conclude. By the way, hence the name perfect square trinomial. Back in the day, I think it's from, I don't know, the Greek or the Arabic. So they the one who figured this out using geometry. Of course, they write more complicated what we do right now because we have notation. But back in the day, instead of writing like this, they use subject, like they use geometry. So the math that you're learning today is actually based on geometry. We just write things in algebra. All right, the second one, let's do the second one. Okay, I want to find the area of this big rectangle. So I don't know why they denote a region, they call R for region. Okay, so I want to find the area of the big rectangle. So I want, what do I want? I want R. I want big R. Big R is what? Is equal to, so in order to find the big area, I have to do what? Sum up all the little areas. So some R1, R2, R3, R4. So the big R is equal to R1 plus R2 plus R3 plus R4. I'm gonna coat this with color. See, you can see that. And then black. All right. Okay. Can someone tell me what's the area of R1? A times A, which is A squared, right? So A squared. What the area of R2? Remember, area is length times width. Length is, what's the area of R2? Length is AB. A, yeah. Width is B, so AB, right? I put it in yellow, so plus AB. What's the area of R3? Also AB. Do you guys see that? Everybody see that? Length times width. Length is A. Width is B. What's the area of R4? B squared. Is there any like term that I can combine them together? Yeah. 1AB, so 2AB. So rewrite A squared plus 2AB plus B squared. Now, what is the area of the big maybe I'll write it in what color should I go? Let me Green it is, green. If I ask you what's the area of the big R, what do you tell me? Area of the big R. What's the length of the big R first? What's the length of this? Too high. The length of, what's the length of this? A plus B, right? Is here also A plus B. So A plus B, A plus B. So the area of a big R is what? Yeah, A plus B times A plus B, because length times width. Here, width and length are the same, which is equal to A plus B squared. A plus B squared. Maybe I'll write down here. Okay, so this equal this, equal this, equal this, equal this. So conclusion is what? This one equals this one. Right? So two examples, and we prove by geometry that that they equal mathematically, right? So part C, equate the area from part A and part B. We have A plus B quantity squared equal to A squared plus 2AB plus B squared. And it's the same thing for the minus case. All you do is just change the sign. So those two here, two things I highlight right there. On the exam 2, I'm going to give you this. You're supposed to factor it using AC method, or you can see it right away, which is great. But if you're not using AC method, go back to this method. Reverse engineer. Okay. How to factor a perfect square trinomial. First, I'm going to determine if the leading term is a perfect square. If the leading term is a perfect square, means something like 4. So I can say that, oh, 4 is 2 square, right? Or 9 is 3 square. If I give you 7, definitely not a perfect square, right? You cannot square that. Or 15 is not perfect square. So if the leading term is perfect square, then you can written as a square, right? Or like 2 square, 4 square, 5 square, stuff like that. I'm gonna go through the step as I'm gonna do example 2A. 64x squared minus 80x plus 25. Is 64x squared is a perfect square? Yes, because I can write it as what? Ax, all of that square. Make sure you put a parenthesis, meaning the square belongs to both of these, not just x. So yes, the first term is the perfect square. Second step, determine if the constant term is the perfect square and positive and can be written as b squared. This one is a perfect square. Yes, right. So I'm going to leave a little space, plus 5 parentheses square. You don't have to do parentheses, but just good habit. And then the third step, determine if the middle term is equal to 2 times a times b. Oh, by the way, this one right here, that's what? That is your a, and that's your b, right? A squared, b squared. So the middle term will be what? 2 times a times b. So what's a is ax, and b is 5. Do not distribute. This is not plus or minus. Plus and minus, you distribute the 2 twice. But because it's multiplication, you just multiply straightforward, right? If I ask you to, don't write this down. If I ask you this, 2 times 3 times 5, what do? Do you distribute? No. You do it. 2 times 3 is 6, 6 times 5 is 30. That's it. You're done, right? You don't do like this. 2 times 3 is 6, and then 2 times 5 is 10. 6 times 10 is 60. 30. Okay? So distribute. Just multiply straight. That's it. 2 times 8 times 5 is 80. Thank you. 80x And then 5 squared is 25. Actually, I don't want to write it down. No, I don't. I'm just checking. I don't have to write it down. What is the sign for in front of 2? Minus or plus? Minus, right? Minus. So yes, it is a perfect square. So perfect. So now all you so this part right here, you confirm that it is perfect trinomial. All you have to do is what? Remember this? This equal this. All you do is a plus or minus b squared, right? In this case, minus. So what is a here? A is ax, right? B is 5, and then in between is minus or plus? Minus or plus? Minus, right? Minus. And you're done. Of course, there's different way to do this. Did you know that already? What's this called? What? AC method? Right? If you want to use that, that's fine too. Okay. Why don't you guys? Ooh. I'll do B with you. I'll do B with you. All right. Let's see if B is also a trinomial perfect square or perfect square trinomial. Is the first term is a perfect square? Yeah. So how do I write this? Maybe I'll use blue. 7x and then all of that square. Very good. And then the last one. Square outside, and then B will be 6y. So the one in the blues the blue one is A and B, right? Plus or minus 2? Plus, right? Because they all plus. Or this one is plus. And the last one always got plus. The first last always positive. A is 7x and B is 6y. And you can check, right? You can check 2 times 7 is 14, 14 times 6 is 84. So yes, check. So you say yes, it is a trinomial. And now you can factor using the pattern, right? It's a plus b squared. A is 7x and b is 6y, and then plus. Let me box my answer. Why don't you guys try C before I give you try? Oh, first of all, what do I have to factor out? What is the GCF? Do all three terms. What else? Oh, remember, GCF is the first step you do everywhere. Factor. If we're factoring it, we can GCF first. So 3y. What's left over? Let's see. Let's see. Yeah, 27 divided by 3 is 9. Right? And then there's the x squared. And then y divided by y is 1. So we're not going to write it. Then the second term was left over. 90 divided by 3 is 30. 30 what? 30x. And then the last one, 75 divided by 3. Huh? 25. That's it, right? 25. Okay, so leave 3y alone, right? It's the one that we factor. So we just kind of ignore it for now. We bring it back when we're done. What we're gonna do, focus now, is inside the parenthesis. Is 9x squared is a perfect square? How can we write this? 3x, very good. And then the 25, can we write it as, yeah, 5 squared. Let me move it out a little bit so I have more room. 5. And then the middle one, 2 times a times b, and we know a is 3x, b is 5. Maybe I shouldn't put this dot there. You're gonna distribute. And then in front of 2, plus or minus? Plus, always plus at the last one. 2 times 3 is 6, 6 times 5 is 30. Yes, right, so check, right? You gotta check, so it's 30, so yes, check. And it check everywhere, it checks first, middle, last terms. So it is a perfect trinomial, so what do? Something plus something squared, right? And that something is gonna be a, which is 3x. That's right. Thank you. And don't forget the 3y that we kind of grayed out earlier. We're gonna bring it back. You try. Nine x squared plus 12x plus 4. Let me give you a hint. The answer should be in the form a plus b, all of that square, okay? It's not a plus b times a plus b. It had to be in that form, a plus b, all of that square. Just like we've been doing. Oh, sorry, hang on. I don't know what, I thought I fix it. If you refresh your Moodle, it should be okay. Pick the U try 2 as well. All right. Objective 2, factor difference of 2 square. Again, you know this already. Let me remind you, you know this, recall. If I have a squared minus b squared is equal to what? On the exam, you did this. But maybe I should do the other way around. A plus b times a minus b equal. You did this on the exam. It's a conjugate, so the middle term cancels. So what's left? It's just what? A squared plus b squared. I'm sorry, minus b squared. Right? Remember you on your exam you did this? Or you can FOIL it. You see the middle term cancel out. All right. Again, back in the day, people used geometry to represent this. They don't do what we do today. It's modern math. Right? Back then they used shade, right? Whatever they had. Okay, so let's do this. They have so many R. All right, here's the deal. I want to find this area. Let me highlight the area that I want to know. I want to find a shaded area. So everything except the one that it's not shaded, non-shaded. Right? I'm gonna call the non-shaded are not the region R sub 0, non-shaded, right? And then the region that I'm looking for, the one that I shaded here is R. Okay. I'll call this R. So so what's the area of R naught? Maybe I'll do R naught in blue. What is the area of R naught? B times B, which is B squared, right? What is the area of the shaded region? Hang on, I shaded wrong. Ooh, I shaded wrong. Hang on. No, I shaded wrong. Triple, it's too complicated for you guys. Maybe just the whole square. Like that. I want to find the area of the big one. Everything. So what's the area of the big one? A square. Very good. Which is a square. Now, this should be the last. The one I want is the shaded area. I don't want the one non-shaded area. So the one I want is this one. Well, you have the big area, you have the small area. In order to find the one within, what do? In order to find the green one, what do? You have this, you want this. Yeah, you want the big one, subtract the smaller one, right? So the green one, R here, shade area is equal the red one, subtract or not. The rest one is a squared, subtract b squared. So we have the right hand side, a squared minus b squared. Let's see if we can use geometry again to figure it out. Is it true? A squared minus b squared is equal to a plus b times a minus b. Using geometry. So we agree that the length of this one right here is a plus b. And the side one is a minus b. What is the area of a rectangle? The whole thing. The area of the big rectangle is length times width. Length is a plus b, width is a minus b. If I was you, I'll FOIL it, see what happened. And you kind of know what happened already because you took exam on this. The a squared, a times minus b is minus ab. B times a is the same thing as a times b, so plus ab. And then b times minus b is minus b squared. What happened to the middle term? They canceled out because they opposite, right? All you have left is a squared minus b squared. And it is true, a squared minus b squared is equal to this. So on exam 2, on exam 1, on exam 1, I think you given this, the answer should be this, right? On exam 2, you get this, the answer should be that. Reverse engineering. Okay, let's do that. Again, remember the rule. Determine whether each binomial is a difference of 2 squared. If it is, factors. Step number 1, I want to check there are 2 terms and the operation is subtraction. Yes, the 2 terms. 1, 2. And the operation is subtraction in between, so yes. Determine if both terms can be written as a perfect square. Can I write 100x squared as a perfect square? How do I write this? 10x, thank you. And then what about the 1? 1, right? 1 squared is still 1, so 1. Oh, I forgot the x. And that's it, you done. So you can rewrite it, yes, so you say yes, it is a difference square. Diff mean different, I don't have enough space, so. And then now you confirm that it's different to square, you use a formula. Your A is the one in blue, and B is also the one in blue, so it's the second one. So two binomials, right? And A plus B, so 10x plus 1, and A minus B, so 10x. Let me write better. This is 10x minus 1. I want you to try C first before we try D. Why don't you try C? Yeah. What you have? What do you guys have? So first of all, it is two term, and then operation is minus, right? And then next you check if it is different to 2 square. So how do I revise 6 square? Thank you, Kyla. Then the second one. And it is, right? Different 2 squares. I don't want to rewrite that sentence again. I'm just gonna do double check mark. It's the same thing as before. Okay, so factor it. Factor it. There's a plus, there's a minus. So a plus b, right? 4x plus 11y, right? And then a minus b, so 4x minus 11y. So far, so good. Yeah. Let me ask you a question. Is would I be able to factor b? No, right? If I'm not able to factor something, what is it called? Remember? Prime, right? Prime. We can check. We can check. See, let's check. Say you don't have to write this down. It's just if I have 10 minus no. If I have say 100 minus 9, 100 minus 9 is what? 91. Okay, 91. Is 100 a perfect square? Yeah, so I'm gonna check with this formula. I'm gonna check with that formula. So 100 I can rewrite it as, don't write this down. 10 squared, just listen. 10 squared, and then in the 9 I can rewrite is what? 3 squared, right? 10 squared, 3 squared, that's different than 2 squared. I can rewrite further more, would be what? 10 plus 3 times 10 minus 3. 10 plus 3 is 13. 10 minus 3 is 7. What 13 times 7? 91. So yes, it checked, right? So which it checked because it's true. The formula is true. Now let's check if it's the plus. Let's check if it plus. Add. Well, 100 plus 9 is 109. Let's check if it. Let's check. So here I have plus. So I have to plus everywhere, right? So 13 plus 13. 13 times what? 13 times 13. 169. Which is not it, right? So we don't have any formula that allow you to do the sum of two squares, right? Sum of two square. So we call it prime. And again, it's failed the first step. The operation is should be subtraction. Here's minus plus. Right? So whenever you see something like this, is prime. Actually, let me give you one. Write this down. Is this prime? Is this prime? Why? Yes and no. Both answers. You gotta break it down more. I don't think I can break it down, but I can factor something out. I can factor something. What's a common factor between? No. 4, right? The common factor is 4. So before I can say prime, I gotta factor the 4 out. So 4 times quantity of x squared plus y squared. Now is prime, right? So like yes and no. So that right there is. But before you can say prime, you gotta factor the 4 out. So be careful on the exam if something like that. Again, GCF is the first thing you're looking for. Always. D, is it difference 2 square? Well, the step 1 is satisfied, right? It's a 2-term operation is minus. 49, I can rewrite it as what? And then x squared is x here. And then, so yes, is a difference 2 square. Just don't want to write it down. Plus and minus. So 7 plus x, 7 minus x. Is that okay if I write 7 minus x first and then times 7 plus x? Yes, it's okay. Don't bother to change. I know sometimes it's just like, oh, maybe I really want to change the x plus 7 and then change back to x minus 7. Now, 7 minus x is not the same as x minus 7. 4 minus 3 is not the same as 3 minus 4. Last one, and I'll give you the you try. This one is 4x to the 4 minus y to the 4. Is it different than 2 squared? Well, first of all, is it satisfied the first condition? Is 2-term operation is subtraction? Yes, right? So yes, so let's move on to the second condition. Is 4x to the 4, I can rewrite it something square. 2x what? So 2x squared, and then square outside, right? You can check, you distribute it 2 squared is 4. X squared is x is 4. You multiply or you add? When you distribute the power, multiply, right? You multiply. And the second one will be y squared plus minus. So 2x squared plus y squared, and then 2x squared minus y squared. Can I factor any more? I know this one is prime, right? This is plus. No GCF, so we good. Can I factor this one? I'm itching, but can I factor it? What do you think? It's x squared minus y squared. It will do that. I want to factor it. But I cannot because what? 2, right? What number when you square give you 2? None. Well, at least not in integer, right? Square root 2. But right now you cannot factor it. If it's like this, and yes, you can do more. Go ahead, do more. Expand it x plus y half x minus y. But there's this one here in a way, so we just kind of stop it right there. Maybe it's a good news for you guys. You don't have to do more. All right. You try 2. 64x squared minus 81. I just fixed it. Yeah. How about the other people? You guys be able to do it? No? Oh, darn. 10, 10. Okay, my bad. Hang on. All right, refresh it. Should be good now. Thank you. All right, one last one. Just hang with me. I know it's just like, oh my God, my head is saturated. But hang with me. This one last one will be done. So at the first objective, second objective, we did about square, right? Now we're gonna come to cube. It's cube. Let's do this. I want you to FOIL this, or I don't know what it's called, FOIL it or distribute, because there's binomial and trinomial here. Anyway, you do what you know to do, right? So a times a squared, which is a cube. Right. We put it in black. A times AB. Very good. A squared B. A times B squared. A times B squared is AB squared. Right. Let me move it down a little bit. All right, so I'm done with the A, now the B. Be careful of the sign. Negative B times A squared. negative ba squared or negative a squared b, right? I like to write my a's first. Negative b times ab, negative ab squared, very good. And then negative b times b squared, minus b cubed. Is there anything I can combine like term? Right. So a cubed is nothing there. A squared b squared. A squared. Let me do like this. A squared. No, is there? Oh yeah. So what happened to them? They cancel, right? They cancel. What else cancel out? Yeah, that one too. Or two. So they cancel out. So it's just a cubed minus b cubed. Isn't that nice? If I give you this, can you do that? No, Mimi. How? There's no AC methods here, right? AC methods only work.
Here's what I found.
Well, if Siri knows something. But of course, you're not allowed to do Siri on the exam. So AC method only work with what? A binomial times a binomial, right? We have binomial times a trinomial. So something else, right? Here's a formula. I'm just gonna give you a formula. Let's write this down first. Do you have to write this down? No, you don't have to. Right here. Right here. A cubed minus b cubed. And I'll explain it to you, and I'll help you I'll help you the way I think it's easier for you to memorize this. So here's a formula. So highlight that or write it down, whatever. And here for the a cubed plus b cubed. It's the same thing. What's different? The side of the first, the binomial, right? And then the side here. So again, don't worry about it. I'll show you the way to remember it. Now, do you guys remember if I have a squared plus b squared, what do we call it back then? We don't have anything we don't have any formula to factor it, so what do we call it? Crap, right? A squared plus b squared crap. But it's not the case with a cubed plus b cubed. There's something. Okay, so let's do this. So you agree that a cubed minus b cubed equal that, right? Because that's what we come up with by FOIL it. Let's do part B. Let's do part B. A minus b quantity squared, quantity cubed. Let's FOIL it out. What happened? Let's FOIL out, see what happened. I'm gonna FOIL the first two first. So a times a is a squared. What else? A times minus b minus ab minus b times a minus ab again, and then minus b times minus b is positive b squared. And of course, rewrite the third one, a minus b. We haven't touched that, the third binomial yet, so just bring it along. Can I simplify in something here? Yeah, becomes what? Very good. Close to what? Minus 2, right? Minus 2 AB. Minus 2 AB. Plus B squared. And then again, bring along that A minus B. I'm done with the binomial. Now I'm continue. A squared times A. Oh, A times A squared doesn't matter. Is A cubed. A squared times B minus AB, I'm sorry, minus A squared B. Negative 2AB times A. Negative 2A squared B. Right. minus 2ab times negative b, positive 2ab squared. Two more, almost there. B squared times ab squared. And then last one, yay, b squared times negative b minus b cubed. Let's combine like term. A cubed, b cubed is nothing there, but I can combine something. I can combine this one with this one, which is what? Close. Minus 3 or 3? Minus 3a squared b. Right? So the blue one, yellow. This one and this one. Plus 3ab squared minus b cubed. Wow, look at that. Oh my God, which one you prefer? I prefer the left one. So as you can see, this is, I don't want to say proof. I want to show you that a cubed minus b cubed is not equal to what? A minus b quantity cubed. Are they not equal? Look, one is this, one is that. Are they not equal? So please do not, on the exam, if I give you something like that, do not distribute. Do not distribute. That's wrong. Okay? So write out 3 times, which I'm not gonna do that to you. Anyway, no, I still have 6 more minutes, right? I'm not gonna do C because it's the same thing. You're gonna cancel a lot of things out, and then at the end, what do I have? At the end, what should I have? If you distribute, I'm not gonna do it. If you distribute it just like you did in part A, the middle term is gonna cancel out. So at the end, what should I have? A cubed minus B. Let's say A cubed, B cubed, right? I know that I got A cubed and B cubed. Minus or plus? Careful. Let's start with minus. So I have minus. Let's start with plus. So I have plus. You can do it at home. Please do it at home. But I don't feel like we don't have time to do it. All right. So let's do this. Oh, by the way, this is how I remember this. Let me show you how I remember so you can do your workshop. When I given something like this, what I do is you load down a little bit so I can reach it. If I give an a cubed plus b cubed, by the way, it's not always one term. Okay, it could be something. I prefer parenthesis cubed plus parenthesis cubed. What I'm going to do is, I know that I'm going to have a binomial and a trinomial. For the binomial, I'm going to cover the cube. I got what? A and B. For the trinomial, how do I come up with these? Well, a times a is a squared, b times b is b squared, and in the middle, you do what? A times b. That's how I remember it. Now for the sine, what happened? For the sine, oh, it go to sleep. I got some %. For the side, it's gonna be soap. Soap, like soap you wash in your hand. So same. So look at the original same, opposite, always positive. Same, opposite, always positive. So soap on the side. Okay. So that's how I remember it. Let's do one more and I'll let you go. Oh, 2 more, see how fast we do. Fill out the blank. X cubed plus a, it's the same thing as x cubed plus what cube? It's give me a. 2 cubed, thank you. And this is some difference of 2 cubed, a sum of 2 cubed, right? The binomial and trinomial. And then remember what I say? The first one will be what? X and 2, right? That's your a and b. And then the trinomial is what? X times x is x squared. 2 times 2 is 4. And then the middle one is x times 2 or 2 times x, or same thing, so 2x. Sine. Same. Opposite, always positive. Or always plus, whatever. It's shorter than positive. Then you done. One more and I'll let you go. One more, I'll let you go, I promise. Let's do this one. 27x cubed minus 8. How do I rewrite 27x cubed? Something cubed. So what number when I cube give me 27? 3, right? And then the x, right? And then the 8 is 2. Oh, should be minus here. Typo, sorry. Typo. All right. So what's my A? A is whatever inside the parenthesis, right? A is 3x. 3x, right? Whatever inside the parenthesis, that's your little a. B is 2. A squared. 3x times 3x. If you don't know how to do it, write it out. 3x times 3x is 9x what? Square, right? And then 2 times 2 is 4. And then 3x times 2 is 6x. Someone give me the sign. And then we can leave. Yeah, the whole way positive. Let's do soap. Same with the original. Opposite. So opposite original is plus and always positive. Right? Yay, done.